Hey guys, Mr. Milton here. Today we're looking at writing exponential functions notes. At the end of this video, you should be able to write an exponential function from a graph or from 2 points. Okay, remember that there are two things we need to write an exponential function. We need the a value and the b value. That's it. Okay, our starting value and our growth/decay rate. If we know those two things, then we can write an exponential function. Okay, and remember that our shortcut kind of explains those two things. Okay, we know that our starting value is our y-intercept. And so in this case, our starting value is 4. We can find our b value by saying where we go from there, or where we've come from. Okay, and so as we move from the right, we went from 2 to 4. What did we have to multiply to get there? Well, we multiplied by 2. We went from 4 to 8. We multiplied, so we can feel pretty confident that our growth factor is 2. So we have y equals a times b to the x. Número 2. We can do the same thing. Where do we start? Our starting value is at 15. Where do we go from there? So we go from 15 at 1, we are at 5. What do we have to multiply by to get from 15 to 5? And some people say, well, we divide by 3. Yes, we divide by 3, but remember that we have to think of our growth value or our growth/decay rate as what do we multiply by. So dividing by 3 is the same as multiplying by 1/3. That is our decay rate. Again, it's a decay rate because it's less than 1. This is a growth rate because it's greater than 1. And so we plug our values into our formula or equation. Y equals a times b to the x. Okay, that's great from a graph. What about if we're just given 2 points? So it says write an exponential function from the given 2 points. I gave you 2 points from the exponential function. Which letters do they represent? Remember that they will represent x and y. Okay, and so plug those values in it, and now we have a system of equations. Except these equations are not linear, they are exponential. That means that we have to solve them differently. So here's how our system would look, right? Because our function would usually be, and write this in different colors so we don't get confused, y equals a times b to the x, okay? So since we have y and x, so our y value here is 12. Don't know a, don't know b, our x value is 1. For the second one, our y value is 36. Don't know a, don't know b. Our x value is 2. And actually, I'm going to do something to help myself out. Let me see. Yep. All right, I'm going to do that backwards. I really like writing. Oops. I really like writing it so that my bigger y is on top. And I'll show you why in a little bit. A times b to the 2, 12 equals a times b to the 1. All right, so what we have is a system. Here's how we solve it. We will make this into a division problem. 36 equals a times b squared over 12 equals a times b to the 1. Okay, and I'm going to divide these two. 36 divided by 12 gives me 3. A divided by a cancels out. B squared divided by b to the first. This is where our exponential functions comes into play, right? So b, 2 minus 1 gives us b to the first. Notice what cancels out. The a value. Because of this, we can find the value of the other needed piece. And once we have that, we can plug it in to solve for the other one. So I found out that b is 3. So now in this equation, either one, I can say, okay, 12 equals a times 3 to the first. And 3 to the first is just 3. I can solve for a now by dividing both sides by 3. And I get 4 equals a, or a is 4. And so now I have my starting value of 4, my growth factor as 3. And I can write my equation as y equals 4 times 3 to the x. Okay, let's do that with some more problems here. Writing my equation, my system out, 96 equals a times b to the third. 48 equals a times b to the second. Do my division. 96 divided by 48 is 2. The a's cancel out. 2 minus 3, or 3 minus 2 gives me b is 2. Okay, once I find out that b is 2, I plug it back in. I'm going to plug it into the second equation. I get 48 equals a times 2 squared. In this case, I have 2 squared, so I need to see what that is. 48 equals a times 4. Divide both sides by 4. 12 equals a. So I have that a is 12, b is 2, and I can write my function now. Y equals 12 times b to the x. Number 2. Got 20 equals a times b to the first. And I've got 5 equals a times b to the second. Okay, so doing the system, 20 divided by 5 gives me 4. Our a's cancel out. And here, I'm going to subtract the 2 from the 1. And I get b to the negative 1. I have a negative exponent. Really don't like it, but it happened. How do I find out what b is? Well, remember that we can find out what b is by flipping it. So 4 equals 1 over b. And in order to get b out of the denominator, what I'm going to do is I'm going to multiply both sides by b, and that gives me 4b equals 1. Divide by 4, b equals 1/4. All right, didn't love it, but now I have b. b is 1/4. And so now I can plug that in and see what it's going to be. I'll plug it into the top. 20 equals a times 1/4 to the first power. And that's just 1/4. And so now I have to divide both sides by 1/4. Remember, that's the same thing as multiplying by 4. And so I find that 80 is a, or a is 80. So a is 80, b is 1/4. My function then is y equals 80 times 1/4 to the x. A couple more here. I've got 27 on top equals a times b to the x. 3 on the bottom equals a times b to the, oops, I said x and it should be 3. All right, divide our function. 9 equals b squared. Okay, I have b squared. I need to find out what b is because it's a squared. I can take the square root. Remember, those are inverse operations. And so I find that b is 3. Now that I know that b is 3, I'm going to plug it in to this function and say 3 equals a times 3. Divide by 3, a equals 1. So y equals a times b to the x. And finally, I'm going to do 54 equals a times b to the 3. And 90 equals a times b to the 2. Okay. I got 54 over 90. What does that give me? 6 over 9, 2/3. That simplifies to 2/3. And I like fractions here. Fractions are going to be better than decimals. Our a's cancel out. 3 minus 2. So b equals 2/3. Okay. B equals 2/3. I'm going to plug that into one of the functions. I'm going to do the bottom one because that is the lower exponent. So 90 equals a times 2/3 squared. Have the square that. Remember, that means I'm distributing that to both terms here. So 90 equals 4/9 times a. To get a by itself, I need to multiply both sides by the reciprocal. So the 9's cancel out, the 4's cancel out on this side. We get 810 divided by 4, right? 202.5. Nice. All right. And so here we have it. Y equals A times B to the X. All right. And that is writing exponential functions. See ya.